Hello viewers, welcome to the Chemistry Department of Mallabhum Institute of Technology, Bishnupur. Myself Mr. Nikhil Kar, Assistant Professor of Chemistry, and Mr. Somnath Chakraborty, Technical Assistant of this department. Today we are back with another video of BTech First Year Basic Chemistry Experiments. The name of the experiment is to determine the coefficient of viscosity of the supplied sugar solutions and hence determine the concentration of an unknown sugar solution. For this experiment, we need a salt viscometer, stopwatch, burette stand with clamp, pipette, beaker, weighing balance, and specific gravity bottle. This is a salt viscometer. It contains two bulbs. Bulb A is larger than bulb B. Bulb B is at the upper side of the narrower limb. At bulb B, there are two marks, one above the bulb and the other below the bulb. A capillary tube inside the narrow limb is connected with the bulb B through which the liquid will pass. At first, we enter a definite volume of liquid into bulb A from the top of the broader limb with a pipette. Then the liquid is sucked up to bulb B up to the upper mark. Then we let the liquid fall down from bulb B through the capillary tube. We note the time within which the liquid passes from upper mark to the lower mark. We can directly use Poisson equation to calculate the coefficient of viscosity. In this equation, R is the radius of the capillary tube. The measurement of radius is very difficult. A small error in the measurement of radius leads to a large error in the measurement of coefficient of viscosity. So we want to use the Poisson equation directly. Instead we calculate the relative viscosity coefficient of the liquids with respect to water. And we use this equation instead of Poisson equation. Rho S and Rho W are the densities of the solution and water respectively, and Ts and Tw are the time of fall of the liquid and water respectively. For this experiment, we need sugar solutions of strength 5%, 10%, 15% and 20%, and a sugar solution of unknown strength and distilled water. At first, we measure the weight of the empty specific gravity bottle with lead, and the weight is 11.51 gram. Now we fill the bottle with water, place the lid and wipe out excess water present on the outer side of the bottle, and then measure the weight. The weight is 33.43 gram. Then we empty the bottle and fill the same bottle with 5% sugar solution. Placing the lid and removing the excess water present outside the bottle, we measure the weight, and the weight is 33.78 gram. Similar way, we measure the weights by filling the specific gravity bottle with 10%, 15%, 20% and unknown sugar solution. We have noted all the weights in a table and calculated the ratio of densities of solution to water by using the equation rho S by rho W equal to W3 minus W1 divided by W2 minus W1. For 5% sugar solution, the calculated ratio is 1.016, for 10% 1.032, for 15% 1.048, for 20% 1.064, and for unknown sugar solution it is 1.026. Our viscometer is well set by the burette stand and clamp. Now we are filling the lower valve of the Oswald viscometer with distilled water with a pipette. Then we suck up the water to the upper valve. Then we measure the time for the distilled water to pass from upper mark to lower mark of valve B. As soon as the water meniscus leaves upper mark, we start the stopwatch, and when the water meniscus touches the lower mark, we stop the stopwatch. And for distilled water, it takes 29.03 seconds. We will note this value. We repeat the same process with 5%, 10%, 15%, 20% in unknown sugar solutions and note the corresponding times for them. Then I calculate viscosity coefficients for all the solutions separately by using this equation: eta S equal to eta W equal to rho S by rho W into Ts by Tw. Then we prepare a table of two columns. In one column we write the strength of the solutions, and in the other we write corresponding viscosity coefficient values. From the table, we draw a graph taking strengths at the x-axis and viscosity coefficients at the y-axis. From the coordinate point of viscosity coefficient of the unknown sugar solution, we draw a perpendicular onto the x-axis. The perpendicular cut the x-axis at 7%. So the strength of the sugar solution is measured 7%. Thank you for watching this video.